This video will focus on combining the concepts of molar mass and mole ratio into one idea. So it really goes with the target. I can utilize previous knowledge of chemical reactions to apply stoichiometric calculations to a chemical reaction. So from here on out, when I use the word stoichiometry, what I'm talking about is right here. Okay, stoichiometry, or the study of stoichiometry, is that we use the relationships that are established in the chemical reaction, so relationships we already learned how to do with subscripts and coefficients, in order to determine quantitatively how much of each will be around or present during a chemical reaction. So the actual word stoichiometry, since it's such a weird word, I like to always tell you that it comes from basically the meaning of measuring elements. So the problem is, as I've said, we can only count elements, but when it comes to predicting what's going to happen, we are massing them because we can't count them. So stoichiometry is the relationship between counting and massing. Because the definition of stoichiometry requires that we go from one substance to a new substance, right? It's looking at the relationship between the two things. Essentially, what stoichiometry is in a nutshell then is that we use mole ratio. So the mole ratio is the relationship that allows us to convert from one substance to a new substance within the confines of a chemical reaction, which means when you're doing stoichiometry, at some point you will always use a mole ratio, and that will allow you to go from one substance to a new substance in the question. So when we think about the two main conversions we've seen so far, essentially the molar mass will allow us to convert from moles to grams or grams to moles for any one given substance. And then the mole ratio is what will be used to get us from one thing to a new thing, which is what stoichiometry is. It's relating two separate chemical things together. So a couple hints when it comes to problem solving, okay, up here. Number one, you must have a complete and balanced chemical equation to do stoichiometry. Since stoichiometry is based on how the substances are related in the reaction, if you don't have coefficients, you don't know. Okay, so it's again the idea that if you have a recipe but you don't have the proportions, then you really can't make it. Okay. Once again, reminder, all stoichiometry problems will go for the mole ratio at some point. That'll get you from one substance to a new substance. And then when it comes to solving, it's similar to what we've done. So come up with, where you start, where you're going to end. Kind of that's organizing what you know, right? What I have and what I want. And then we use dimensional analysis to get us from start to finish, so kind of set up that roadmap and then solve the problem and verify that you think it makes sense. So I'm just going to do one example problem on here. We'll have plenty of problem solving time, but essentially it's just combining the two, again, conversion factors that we've already talked about in class. So I'm going to do this problem. If you have 25.6 grams of hydrochloric acid, HCl, and you react it with plenty, which we call excess sodium metal, the question is how much hydrogen gas will we produce? That word excess is in the problem to simply say you have plenty of it. It's not going to limit your production. Okay, eventually we'll get into problems where we have amounts of each reactant, and then we will have to worry about which one's going to limit. So given this information, hydrochloric acid is the thing that's going to run out. It's going to be the thing that determines how much product is made. So to start, you need to create a complete and balanced chemical equation so that we have our coefficients in order to make a mole ratio. So for this problem, again, it was hydrochloric acid reacting with sodium metal. So utilizing our previous content, we can see that this is a single displacement reaction that will occur. And then you always have to remember to balance it because we need those coefficients. So there is the first step always. Second step is to do what we were doing before, which is figure out where you're starting and where you're going to end. When you're determining your starting point and your ending point, it's important to not only label in terms of the dimension, grams, but also the substance. Since we're changing substances within these problems, we need both pieces of information. Then, like all dimensional analysis problems, we will use some kind of relationship to move us forward. Okay. Couple things of note for me. Number one, I see I'm going from one substance to a new substance. So I'm for sure going to have to go through mole ratio at some point. Okay, so a mole ratio has got to happen. Okay. So when I see that I'm in grams, though, that means I have to get to mole. And if you see grams and you think, oh, I need mole, boom, molar mass. Okay, molar mass is kind of your comfort zone. It's the thing you need to be able to do. I would also label these with substances so that I remember where I am right now. Okay, so I'm not yet in grams of H2. I'm going to use another relationship, right? Whatever's here is coming down, so now I'm in mole of HCl. And this is my mole ratio. This is where I can now go to a new substance. And the information for the mole ratio is given to me in a balanced equation. So coefficient of 1 here and 2 here. Now I'm still not at my goal because while I'm at H2, I need to also go to gram. So I'm going to do one more step to go from mole of H2 up to gram of H2. The information then by the grams will come from your periodic table in terms of the molar masses, and then you simply solve. So to solve this, I go this times 1 divided by that, times 1 divided by 2, times that 2 divided by 1. Okay, that'll get me from start to finish. So the biggest take-homes from this is just combining the two conversion factors we've seen, the molar mass and the mole ratio, into one. The other huge thing about these problems is since there's two pieces of information here, both the dimension and the what I'm measuring, both need to be converted within the problem. Okay, so go ahead and try the quiz and have a nice night.